Okay, today I have a new video for you where I will show you how to write a script in Python 3 for Mac or Windows. Right now I'm going to concentrate on the Mac, but for Windows you would have just to change the path of where your photos are located. And what I'm doing in this script is something that I was interested in computing for myself. I was curious as to what focal length I use the most with my zoom on my camera. And so I wrote this script that walks through a series of folders containing photos, and I have folders organized by year, by month, by day, and so many levels of folders and photos located at different places in there. So my script does that. I give it the root of where my photos are located. It's going to look and it's going to create a histogram. What is the focal length that I use most? So this script generates that. It generates it in text. The idea here is that I don't want to install a sophisticated graphics library. Sometimes they're a little tricky to install. You need extra packages. So this just generates it in text. The idea is to be informative more than generating something that you can embed in some document. We may look at that in another video, but right now, just text. So let me show you what the output looks like. So here I've processed 700 images on my disk, just 1 month's worth of photos. And this is what the output will look like. On the left, I have the focal length. I have the number of images taken at that focal length, and I represent 187 by a series of bars here. And in this case, 60 is the maximum, 60 hashtags. And that is programmable. You can change it, of course. And so it will not list all the focal lengths. It's going to try to compress that. So for example, let's see. See, I don't have 45 right here. I have 44, 46, because for 45, I had no photos taken at that focal length. So it tries to be efficient in that way. So what you see here, what I discovered is that most of the time I'm at 18. I'm using my zoom as a wide angle lens. All right, so let's get started. So here's the script. Again, it's going to be available on GitHub. The link is in the description below. Here are the different constants that you can modify here. The extension, so JPEG, JPEG uppercase, JPEG with an E, ARW. I have a Sony camera, and the raw extension is ARW for these cameras. That's where my EXIF tools utility is located. Previous video describes how to set it up. And this is where my photos are located. It's going to be different for you. You have to figure out the actual path of your photos. And then that is a particular keyword that will appear for that particular lens that I'm using. When I look at the EXIF tool, I found out that 18-135 mm is the description of that lens. So I'm going to look in all the lines generated by the EXIF tool utility. I'm going to look for that, because I don't want the histogram to give me the focal length of the prime lens. I have also prime lenses, and that's not of interest to me. So I want to skip all the photos that are not taken with that particular zoom. Okay, so to show you how I figured this out, let me go here, and let's take just one of them, anyone here. I don't need the asterisk. EXIF tool, that photo. Okay, it gives me a lot of different pieces of information, and that's, so see here, these two lines, for example. 18-135, f3.5, 5.6, lens info. And lens model, E for E mount, I suppose, 18-135, f3.5, 5.6 OSS. So that's the keyword I'm going to be looking for in the EXIF tool. And if I find that, then I will look at the actual focal length. And there's several different focal lengths that will be listed. All right. So that's it. Let's take a look at the code. So I'm using idle again. This is idle 3.5 5.4, so it will use Python 3.5, should work with any version of Python 3. If you have a different version of Python like 2.7, the only thing that you would have to change are the print statement. The print statements in Python 2.7 do not use parentheses. All right, so the only thing that you will need to modify are the extension, the location of the EXIF tool, the folder, and then the length type. So 18.135, we just saw that that applies to what I want to do. So let's go to the main program, which is always at the bottom of the script. So I'm creating a histogram as a dictionary. So curly brackets for that. It allows me to not record focal lengths that are not used. So we saw that 45 was not used. If I had used an array, I would have had an entry for that. So a dictionary is fine for that purpose. I'm going to count how many files I'm processing just to give the user feedback on. It's a slow process, so I want to give feedback as to the number of lines that are being processed, number of files that are being processed. So that's my counter. And then we saw in a previous video that that's a typical loop for walking through a set of directories, and I'm going to start that folder, and I've set that up at the beginning of my program. Getting the file name, getting the extension by splitting the file name. We saw that in a previous video. All right, and if the extension is JPEG spelled different ways, ARW, then I want to process the file. So I'm going to increment the counter by 1, so that's one more good file that I'm going to be looking at. And if the counter mod 50, so I'm dividing by 50, and if the remainder is 0, it means it's a multiple of 50. So at 50, 100, 150, 200, I will print the counter, and I'll say that many images processed. So it's what we're seeing right here. So it will generate that as the program is going along. And Python is not quick, but it's easy to write things like this fairly simply. So that's that part. And then I'm going to call a function to get the focal length. It's the same function that I used in a previous video to find the aspect ratio. So if you want to figure this out, look at the previous video. The only difference here is that I want to make sure that I'm getting there are two things that I'm going to be looking for in the EXIF information: the focal length and the fact that the length type is the right one. So I have two tests here. So if I find the word length and it's my length type in a given line given by the EXIF tool, and length type is 118, 135. So if the word length is in the line and 135, that type is also there, then I will set a Boolean to true. So, okay, I found that line. So if I found that line, then the focal that I will have found will be a good focal for me. If it's not the right length, I don't want that focal. And then if I also find in a different line, so this is part of a loop, so it will go through all the lines. So one line will match here, and I will say length found true. And another line will contain the word focal length. It will be equal to 0. Then what I will do is that I will split the line on the colon, and I've done that in the previous video, and extract the focal length. So I will get that right here. Focal will contain that. And so if the length found is true and the focal is not equal to 0, that variable that I said before the loop starts. So as soon as these two are initialized, then I know that it was the right length, and I have the actual value of the focal. So I'm going to return that. So I'm breaking through the loop. I'm stopping as soon, even before I continue processing other outputs in the EXIF tool output, and I will return the focal length. And if I go through the whole length and that test was never true, then I know that it was not the right length, and therefore the focal that I found is not the right focal. I don't want a histogram. I don't want it to be used in a histogram. So I will return none. And returning none is a way of saying, well, I didn't find it. It's not a valid focal length, so I'd rather return something that is not a number. So that's what none will do for me. Okay, so here, get focal will do that. We'll return a focal. If it's equal to none, then continue in Python will take me back to the beginning of the closest for loop. So I'm going to go back and get another file. So that means that if I'm here, I know for sure that it's a focal for that zoom lens of mine. So if the focal value is already in a histogram, if I've already recorded it, then I'm going to add +1 to the histogram of that particular focal length. And if not, if it's not there, then that means it's the first time that I'm seeing that focal, so I'm going to set 1 for in a histogram at that particular focal value. And that's it. So that's the loop that does that. And at the end, when I come out of the loop, that nested double loop, I will hit display histogram. So I have a function that will take the histogram dictionary and it will display it in the way that I have here. And that's what's going on here. Short description at the beginning to explain what it's doing. Max width here, 60 is the longest line that I want here. So here 60 was a value that worked for me. For you, it could be different. You may want, if you have a wider screen, or you may want to be more a better resolution. You can use 80 or 100, something a little bigger. And then getting all the valid keys, focal values. And if there's none, if my dictionary is empty, then I return. I really want. This is a way of getting making my code a little robust, so that I don't try to do any processing if I have actually no focal values. Then I sort these focals because information in the dictionary is not sorted in order. So I'm sorting that. I'm finding out the largest number, and that's, in my case, it's 187. So, so now that I know that maximum number of focal length at 18, so that maximum number of photos at the focal length 18 millimeters, then that's max num. And so I know that 187 should be equivalent to 60 dashes. So I will use that in my equation. And so now I'm going to go through all the different focal lengths, and now it's sorted. So our list is sorted. So that's going to be 18, 19, 20, 21, and so on. So this loop is going to go through all these different focals. So we can run it, function F5 on my Mac. And you're going to see that it takes a while, so I'll speed this up. But here it's going through the first group of 50, and now it has displayed that 50 images have been processed. So that's right now, it's going to be real time. And then after 100, I'm going to speed this up. Okay, here it is. Okay, that's it. I hope this is helpful. You can probably now get some information about how you use your zoom lens, what particular focal range you seem to be liking most when you take your photos, and that can maybe inform your decision process for the next prime line lens that you may want to buy. Okay, see you next video.